Hello, I'm Abhilash, and I'm here to present our paper Leveraging Self-Attention for Input-Dependent Soft Prompting in LLMs. This paper has been accepted into ACL 2025 as a short paper, and Ananth and Sambaran are my co-authors. This work was done during my internship at Adobe Research. You can scan this QR code to get access to the preprint. So LLMs, they do very well at general tasks, general NLP tasks, but they struggle in domain specific scenarios for which we would have to fine tune said LLMs. However, full fine tuning is resource intensive, of course, because of the number of parameters that LLMs have. An alternative for this is using soft prompting, wherein you have a separate set of parameters that is much less as compared to the number of parameters in the transformer, and only those soft prompting specific parameters would get updated during training, thereby reducing compute. The the drawback with existing soft prompting methods are they are input agnostic. That is, they are independent of the input. However, it makes sense that the soft prompt be dependent of the input in order to improve performance. This is where we come in. We propose ID spam, input dependent soft prompting technique with a self attention mechanism which generates input aware soft prompts using self attention to weigh token importance, right? Uh, and it also maintains parameter efficiency because it's a soft prompting method. So these are our contributions. First of all, it is an input dependent soft prompting method which uses attention. It outperforms state of the art methods on glue and super glue benchmarks, and also does well on zero shot transfer, as we'll see. And during training, it is very efficient when it comes to compute because the number of trainable parameters are much less compared to the entire transformer. So this is the ID spam architecture that we propose. So it computes attention over the input sequence tokens like this, and then it is projected uh, using a down projection and upward projection into uh, basically the latent space, which is then can be appended to any transformer layer in essence. So we break it down. First of all, attention weighted input representation is obtained from the inputs, which is then projected, like up, sorry, down and up using MLP layers. And this is prepended to any transformer layer. So there is flexibility in that. In the experimental setup, ID spam, for ID spam, we use Robota base and large backbones. The benchmarks used are glue, super glue, and we also show results for zero shot transfer. The optimizer used is AtomW. We train for 30 epochs, and the prompt length that we have chosen is 10 tokens. These are the results. So we show first of all the results on the glue benchmark on 6 tasks, as you can see, some NLI tasks, some sentence similarity tasks, etc. What we observe is compared to several soft prompting methods and low rank adaptation, ID spam achieves the highest mean performance and is slightly behind the full fine tuning, which suggests that our method does really well across datasets in the glue benchmark. Similarly, we show the results on super glue, and over here also it achieves the highest mean performance among multiple soft prompting baselines. When considering zero shot transfer, where the model is basically trained on a similar task. So basically it is trained on one dataset first, which has a similar task as the other dataset, and it is tested on the second dataset, right? So we basically carry this on two pairs, right? QQP MRPC and SST2 IMDb. So over here also, compared to low rank adaptation and several other sound prompting methods, ID spam does very well. Then, as we said in ID spam, there is flexibility in where you can prepend uh, the your soft prompt uh, tokens. So what you have observed is appending the generated prompts to the middle layers generally yields the best results. Okay. Coming to the ablation study, we basically wanted to see how important the attention mechanism is, and yes, the attention mechanism improves over simple mean pooling. There is approximately 5.8% gain on an average. Coming to the efficiency, compared to low rank adaptation, it has fewer trainable parameters for different backbones, right? And as the size of the backbone in terms of parameters increases, there are more savings when it comes to number of trainable parameters. Coming to the training time, uh, so basically ID spam compared to fine tuning is obviously much better compared to another soft rounding baseline of LPT. It is either comparable or better, which is a good sign. Finally, we come to certain limitations that we would like to uh, explore later, which is no evaluation on larger LLMs conducted yet due to the compute requirements, and further work is required to automatically select the layer in order to attempt the soft prompt tokens. In conclusion, we propose an efficient input dependent prompt generation method using self attention. It shows strong performance across tasks, and it is also generalizable and scalable, as we have shown in the paper, using different transformer backbones. Thank you.